How's everyone doing? How many of you are here for the first time? Wow, okay, great. Well, this is my third time here, so I'm like less in awe of all of this, but I hope you're enjoying this, and super grateful for everyone to be here today. So I'm going to be giving you another State of the Vuenion. So it's been a quite interesting year, as you know. We've been working really hard on 3.0, and we're going to go over some of the things that went through it, what we did, and why it took so long. Well, let's get right into it. So the bulk of the 2019 was spent on pushing Vue 3 from a research and prototyping stage into reality, and we're really close. So I remember last year when I was here, I was essentially talking about we just started working on Vue 3, we've made a prototype, we've got some ideas, we're trying to validate them. And today I'm happy to say we're pretty much achieved most of the goals that we set out to achieve for Vue 3. So the work left now really is trying to polishing it up, make it stable, and getting everything ready for release. In the meanwhile, let's take a moment and just like look at the stats, which is what I do almost every year for this. We're currently at over 1.1 million weekly active users for the Vue.js DevTools. So the DevTools is the metrics that I personally use to get a relatively accurate idea of how many our general user growth. This is probably does not reflect all the users. We probably have more because some users probably don't use the DevTools, but I personally find this to be a relatively more accurate metrics than, say, GitHub stars or NPM downloads, which just have too many variants to be considered. So a short graph showing our growth from 2017 to 2020. It starts from 2017 mostly because we only published the DevTools in late 2016. So really steady growth, and NPM downloads showing the same trend. Compared to January 2019, that is probably approximately the same time last year, we're seeing 1.7x growth on NPM downloads as well. So interestingly, we didn't actually do big releases for 2.x for the entirety of 2019, but we're still seeing really decent growth. So I think that's a good sign showing that 2.x is really stable and serving its purpose. And that really gives us, allowed us to focus on 3.0 and getting it ready. So State of JS survey, 2018 versus 2019, satisfaction rate didn't really change much, but we can see the red part is the people who've used and will use again. So this total red part is people who've used it, and these are people who have not used it. And the gray part, which disappeared, pretty much disappeared, is people who've never heard about Vue.js. So that's a good sign. Stack Overflow Survey 2019. So Vue is among some of the most beloved tools that developers use. And interestingly, we were not even in the survey in 2018. So another good sign. OK, so let's talk about the journey to Vue 3. So it took a really long time for us to get to where we are today. A lot of hard work went into it. And so I want to sort of take a step back and just look at what really made the journey so long and some of the thought process that went into it. So I divided it into three stages. The stage one, starting in late 2018, which is when we first started the idea of maybe we should consider a new major version, to just laying out the foundation for a new repository, trying out some of the things that we wanted to do. So that was stage one. That is the early foundation experimentation stage. What we did during this stage, first we made the decision to use TypeScript for the new repository. We used Flow in 2.x, and it's been serving us well for a decent amount of time, but Facebook just never want to release 1.0, so it keeps releasing breaking changes on minor releases, and it's getting a bit of, it's becoming kind of a chore to upgrade Flow, and the code base itself, it was aging, right? So we've long had ideas of a better structure in the internals. So we moved to a monorepo architecture. If you look at the Vue Next repo now, you'll notice we divide these internals into compilers, runtimes. We even split out reactivity into its own package. We also use layered design where we have the compiler core, which is platform agnostic. Then we have the compiler, the DOM targeting compiler, server-side rendering targeting compiler built on top of it. We have a new testing setup using Jest, replacing some of the more flaky parts with a test suite that just runs faster and more stable, refine workflow scripts, and establish the RFC process. So most of these work in the early stages during that period of time didn't really bring out any, say, new features or exciting stuff for the end users, but these were actually important work that laid the foundation for us to do further work on top of this. So then in early 2019, we got the first, we essentially got the first prototype which has basic feature completed. So you can actually start an application, render some components, and have state updates. So we completed a reactivity module, we completed a runtime virtual DOM renderer, right? But around that time, so I consider that time to be the completion of the first stage. So we have the new architecture, the new foundation, and we have a basic prototype working. But, and then we started to seriously think about what do we really want in Vue 3. That's the end user affecting new features, new big improvements. And that took quite a bit of time for us to just stop and think about these major new ideas. We want to rethink the runtime update strategy, right? The Vue 3 prototype was fast. We had early benchmarks that showed it was faster than Vue 2, but it was just not fast enough. If we are doing a new major version, we could do better, right? So in stage 2, I spent a lot of time just researching different rendering strategies, trying to find sort of a more fundamental improvement in terms of updating rendering performance. And then we were also iterating on the new API, right? In the early stage, we proposed a class API, trying to offer a better way to use Vue with TypeScript. But as you all know now, the class API didn't really turn out to give us what we want. It just didn't provide enough, and it has its own fair share of problems, mostly related to how the class API is built on top of its dependency, its reliance on a lot of these new native ECMAScript features, which were not really stable at that point, right? Class itself is already in ES 2015. However, we have a lot of features like class fields, decorators, which are still not even in the spec right now. They're still stage 2 or stage 3. So, so we ditched class API, and at the same time, we came up with an idea of a function API inspired by React hooks, and which took quite a bit of time for us to iterate on and try to refine. And many of you probably remember the little upset from the community when we first published the draft of the function API. Many people thought we were going to essentially pull in an Angular 2 and release a version that is incompatible. And we realized, okay, our phrasing was probably wrong, and that was not what we intended to do, so we reworked the whole composition API RFC to better present what it really is, as which is a purely additive layer on top of the API you're used to. and really trying to go from more fundamental concepts explaining where the composition API comes from and how it complements the way we're doing it today. So let's just dig a bit deeper into the runtime update strategy improvements. I've talked about this a few times back in 2019, but I think probably some of you here are not fully, have not really seen the details of what I meant by a faster runtime updating strategy. So the basic idea is the unique advantage of Vue as a framework compared to other rendering strategies. So we have a spectrum of different rendering strategies. So if we take one extreme, say React, React is based on the virtual DOM and is extremely dynamic. And then we have the other end of the spectrum, purely template-based. Actually, Angular, Svelte, Ember, they all kind of fall into this category. They require you to write the template. They compile the template into something that's efficient for updates, but you can only write templates. So once the template is compiled, it becomes kind of a black box. There's no way for you to bypass the template layer and directly work at the renderer level. While for React, it's really flexible. You directly work with the virtual DOM. You can write your own render functions, manipulate it as pure JavaScript. However, it doesn't give you this compilation. Well, you do have JSX compilation, but it's still too dynamic. It doesn't give you this opportunity to have a static template that is very easy to analyze and optimize. So Vue has this unique combination of where we do have templates. We compile templates into virtual DOM render functions. So underneath, we have virtual DOM, but on top of it, we present it via a template layer. So this gives us the unique position to leverage both the dynamic power of virtual DOM. We can expose the render function API for advanced users, library authors, who require the extreme flexibility of JavaScript. At the same time, when you use template, we can leverage the template to do static analysis and perform and produce JavaScript code that's more optimized than what you would produce with manually written render functions. So the bottleneck of a traditional virtual DOM updating strategy is it's very brute force, right? Suppose we have a template like this with a single binding in the template. What the virtual DOM update would do is it would recursively walk the whole tree of these nodes and compare every single one of them, regardless of whether it's changed or not. And then only when it walks onto this node, it will figure out, okay, its text content changed, so I need to perform an update. So on the right, we see the whole list of operations that the virtual DOM algorithm would need to perform, especially when you have another bottleneck, another overhead here is, as we can see, a lot of these elements, they have static attributes, right? Technically, you don't even need to care about these static attributes once they're rendered. However, in a virtual DOM implementation, these attributes are props passed to the V node, right? So when the virtual DOM different algorithm sees an element with props, it doesn't really know whether the props have changed, so it have to do a full property iteration on the props object, compare each of the props to see whether they have changed. Another layer of overhead, right? So having a template compilation step, in fact, gives us the opportunity to optimize away these unnecessary work. And this is what we're doing in the Vue 3 compiler by analyzing the template and breaking them into what we call blocks. So the blocks are segments of your template that is divided by structural directives, essentially vif and v4. So vif and v4 are the only directives that allows you to manipulate the tree structure of your template. So without vif and v4, we can consider your template to have a stable tree structure. So which means we don't need to actually walk the tree if we know the structure is stable. The only thing we need to do is to keep track of the dynamic nodes inside a stable block. So I'm not digging into too much details here. I have past talks on the internet if you are interested in researching more details on the compilation strategy. But here the high-level idea is by dividing our templates into these blocks, divided by these structural directives, we divide a whole template into a few blocks. Each template will become maybe 3 to 4 blocks, depending on how many VIF and V4s you have. And then within each block, it has a stable tree structure, which means we can track all the dynamic bindings like class bindings, text bindings, and all these dynamic bindings in a flat array. So each block contains only one flat array of dynamic nodes that needs to be updated. So we've essentially changed our template updating efficiency from work that scales with the size of your template to work that scales directly with the number of dynamic bindings inside your template, right? So this was one of the weaknesses of Virtual DOM is that even when you have only very small number of dynamic bindings, it still needs to do a huge amount of work to reconcile the updates. So with Vue's new compilation strategy, if you have only one dynamic binding, that's all the work that's needed to do, all we need to do to update the template. So this was the fundamental improvement in terms of performance that we're shipping in Vue 3. And so this is a spreadsheet that I made for the internal comparison with Vue 2. So this row is probably the one that will be most relevant to you. This is improvement over Vue 2 with template compilation and no width. No width means we're stripping the width block inside the compilation output. So this is internal details, but the general idea is if you're using in-browser compilation, you'll be seeing, you'll be looking at this column. But if you're using Vue CLI or single file components with the pre-compiled templates, you're looking at this column. So mount performance, 51%. Average update performance is 133% better. And this is with reactivity included, right? So without reactivity, just look at the raw algorithm improvements. We're seeing over 200% improvements in terms of raw algorithmic improvements. So, but this is a benchmark that's based on updating a huge list of items. Each item has a typical mix of static versus dynamic content. So you probably will have 15 stable static elements and 4 to 5 dynamic elements inside each block. So which should be pretty representational for the average type of components you would author in a typical application. Okay, so so that was stage 2. Stage 2, we really tried to nail like the major improvements that we want to land in Vue 3, and we achieved that. And so this was the performance part, and another big part of it, obviously, is composition API, which we will have plenty of talks on about, so I won't be digging too much into it now. So stage 3, late 2019 until now, really because we've validated most of the ideas, so the work left is trying to push Vue 3 towards feature completion. And as you can see, I've been working pretty hard. We're finalizing a lot of RFCs. We merged a number of RFCs. If you look at the RFC repo now, we have, I think, 19 RFCs merged. So if you are asking, what's going to change in Vue 3? How do I migrate? We will have an official, easier to digest migration guide, obviously, which we're working on. But if you are eager, you're curious, you want to know it now, just go to the RFC repo, look at the merged RFCs. Each of the RFC discusses the migration, the adoption strategy. So you can kind of evaluate how much this RFC would actually affect you. So if you see in the adoption strategy, you will typically see that like something like, oh, this feature is, we can provide a compatible layer for this feature, or we can provide a code mod to help you automatically upgrade. So those are the things you should be looking for. Another major part of work is finishing the new compiler. So we'll talk a bit more about the new compiler in a minute. And then server-side rendering, which we'll also be talking about. So current status of Vue 3, we just released 3.0.0 Alpha 5. We have basic runtime and compiler feature parity with 2.x. This includes all the things like vmodel, transition, keep alive. So most of the features in Vue 2, you can find it in Vue 3 now. Most active RFCs implemented. If you see an RFC, it's probably in Vue 3. And so at this stage, we encourage you to just start playing around with it and help us identify bugs and behavior inconsistencies with Vue 2. The basic idea is that if you find something that's not what you expected, it works differently from Vue 2, first thing you do is you check the RFCs to see if this is an intended change that we have explicitly talked about in RFCs. And if not, then it's probably unintended, and you should file a bug, and we'll look into it. So in Alpha 5, we also shipped basic server-side rendering support. So this should be a good news for Nuxt users. And we're really close to beta, because the last piece of the server-side rendering is pretty much the last piece of the puzzle that we need to complete before we can call it actually feature complete. Now, the new compiler, some of the major improvements we have: full source map support. The new compiler can actually pinpoint an error in your expression back to the corresponding part in your template. We have a new plugin-based transform pipeline. So this improved architecture makes the compiler itself much more maintainable. So if you crack open the source code, you'll see vif is inside its own transform file. v4 is inside its own transform file. Each directive is managed in a transform plugin. So if you are trying to help us fix a bug, it makes it much easier to just find the right place to submit the fix. A layer designed for higher order compilers. Now, we have a compiler core, which exposes these lower level utilities like base parse, base transform, and base codegen. And then it also exports a lot of these internal transforms. So you can build your own compiler on top of it if you want to. And the best example, if you want to do that, the best example to look at is compiler DOM, which is our DOM targeting compiler. So if you look at the compiler DOM, it imports the base compiler's compile function and overwrites a few number of the transforms. Say we have a base vmodel transform, which is platform agnostic, and the DOM compiler can override the vmodel transform to inject additional steps that handles DOM-specific work, like injecting a runtime directive or handling modifiers that only make sense in a browser, etc. So we also built on top of the core compiler to build our server-side rendering compiler, which we'll talk about in a moment. So the new compiler ships with a number of advanced optimizations which were not present in Vue 2. The block-based dynamic parts tracking is what we talked about that offers us the major performance breakthrough in terms of updates. And then we have more aggressive static tree hoisting. We already do this in Vue 2, but Vue 2's render algorithm was not designed with reusable nodes in mind. So there were a bunch of hacks that we had to do. And eventually, there are a lot of cases that we just simply have to bail for static tree hoisting, which made it less useful. But in Vue 3, our new algorithm just was designed with reusable vnodes in mind from the ground up. So static tree hoisting becomes much easier to implement in the compiler. So we'll see some example of this. And then we have event handler caching and stable slots detection. So this may look very abstract. So I think the best way to do it is crack open this template explorer. So this is publicly available at Vue Next Template Explorer.netlify.com, and it's automatically deployed against the current master branch of Vue Next. Yeah, so let's see, basic idea. Let me tick off server-side rendering. And, right, so this is a basic template that's being compiled. I hope you can see this. So this just simply returns a string, obviously. Now let's turn it into a div. And now you see the open block create block thing. So open block create block is the optimization that we talk about. And every template, if it has content, then it has to be a block in itself. Now, if we add nested content into this, as you can see, this span is static, so it's being hoisted here. If we wrap it with more content, now you can see the whole div being hoisted here. And your render function simply reuse the hoisted nodes. Every time it renders, it's just reusing the same node. And when the renderer algorithm tries to diff the two trees, it'll notice that this node is actually hoisted, so there's no work to be done here. Just skip the tree and move on. So this would work for arbitrarily complex structure as long as it's static. We even detect constant expressions. So we know this 1 + 1 is constant, so it's hoistable. It doesn't depend on any scope variables. So even if it's a binding, we still hoist it. Some of the more interesting parts is if we copy this long enough, we notice that, oh, okay, like this is a big chunk of static content, and it has a lot of nodes, a lot of nested nodes, in fact. So how about let's just turn it into a big chunk of string and just set in an HTML instead of creating a bunch of JavaScript objects and walk them and programmatically insert them into the DOM, right? Interesting optimizations here. So there are some heuristics that we use to determine whether we should do this, because based on benchmarking, this is only faster if you do have a certain number of nodes or complex enough static tree. So for simple structures like this, just like mounting them one by one is actually faster. So we do a lot of benchmarking to figure out what is the best output, most optimized output we would get. And what's the other thing that we talked about? Handler hoisting, yes. So if we have a handler, click hello, right? Without hoisting, without handler caching, you see that this gets compiled like on-click ctx hello, and then we have a patch flag, which indicates that this node, for this node, we need to patch its props. We don't need to care about anything else. And the only props that you need to patch is on-click, because that's the only thing that may change. As you can see, if I add a static attribute here, we do have this included in the props. However, ID, because it is static, is not listed as a dynamic prop. So we don't need to care about it. So the only dynamic prop we care about is on-click. And because it has this patch flag, it makes this node trackable inside the current block. So this div will be tracked as a dynamic node in its parent block, right? Now, what the handler caching does is, if we turn this on, we notice that we are doing this weird thing here. So what this expression does is we initialize the handler once, and we dynamically access the actual method to call inside this inline function, and then we cache this inline function for future updates. So so after the initial render, we create this function and cache it. On every subsequent render, we're just reusing the same handler, so that notice that the patch flag is gone, which means this node no longer have any dynamic attributes, dynamic props to diff against. So this actually means it's going to be skipped during the updates, right? So this, essentially, we're making all event handlers optimizable, so we don't need to even diff it. So this also applies for components. Say, if you have a component, right? So previously in Vue 2, if you have an event handler on a component, and especially for this, right? If you have an inline handler, something like this, or test 1, 2, 3, right? This causes it to create a new inline handler on every render. So a common problem in React is like when they use hooks and you have an inline handler, you pass it to a child component. Because you're creating a new function on every render, it will essentially make this component always update when its parent updates, right? So it creates a lot of cascading updates, which is very inefficient. Now, with Vue's handler caching here, we're caching this inline function like this. So when this parent component re-renders, this child component will never update because it just doesn't receive any new props. Okay? So a lot of these minor details that goes into the compiler implementation to make your application run as fast as possible. And finally, let's go into server-side rendering. Okay? So this was the last piece of the puzzle. So previously in Vue 2, so let's go a bit back about server-side rendering. So when React did their server-side rendering, the most obvious thing to do is render an application into the virtual DOM snapshot, and then walk the virtual DOM tree and serialize everything. And it turns out it's obviously slow compared to traditional pure string concatenation templating strategies, because you're allocating a lot of objects, then you're walking these objects, and then trying to serialize them into the string. Now, Vue 2 has a special server-side rendering optimization compiler that compiles your template into something different. So if we go back to Template Explorer, this is the Vue 2 Template Explorer. So if we turn it into server render, we notice it creates something like this. Okay, so we are still rendering it as a virtual DOM tree. However, we turn some parts of the virtual DOM tree into something we call an SSR node. And the SSR node is a node that contains the string representation of this node inside here. Something like this. All right? So we concatenate some of this. However, there are a lot of places that we have to bail, mostly due to how the Vue 2 compiler architecture was somewhat too simple, so that it doesn't give us the enough tools to do proper analysis to figure out in what cases we can still maybe optimize it instead of bailing. Now, in Vue 3, if we put the same template into it, and we turn on server-side rendering, and you notice it's just a single call pushing a plain string concatenation. So essentially, no matter whatever kind of bindings you have, as long as you don't have components in your template, it's just going to be a single giant string concatenation call. Right? So this makes Vue 3 server-side rendering extremely fast. In fact, we're seeing 3 times as faster performance compared to Vue 2. And this will be practically free as long as you use templates. So let's say Nuxt upgrades to Vue 3, and your app will just render 3 times as fast on the server. Okay, so some of the more interesting stuff we can look at for the server-side rendering is if you have a compiler, if you have a component inside your app here, so this component will break up your, let's do this so it's easier to see what's going on. So we have a plain element here, we have a component here, and we have another plain element here. Now, the challenge here is if your whole server-side rendering call is synchronous, it would be really easy. You just push them sequentially, right? However, the challenge is we want to be able to handle asynchronicity in server-side rendering. For example, a component in Vue 3 can have an async setup function. Inside the async setup function, you can pretty much do anything async. You may be fetching data. You may be fetching another component. You may be maybe calling to a cache to cache the render result, right? So there's a lot of things you can do in the async hook, and it's just, which means any component, when you're compiling current component, any child component can potentially contain async work. So how do you resolve that? As you can see, we're still just synchronously pushing stuff here. However, what we're pushing here by calling SSR render component call here is in fact something we call a buffer, right? So a component call, render call inside server-side rendering returns a buffer, which is essentially an array of strings and promises. So you can await on that buffer to wait for it to resolve. So every component call, as you can see, this is in fact recursive because this is a component itself. And what is rendering is a buffer containing some strings, a buffer of a child component, and some more strings. So when you call render to string, you actually end up with a huge nested buffer tree with parallel asynchronous requests contained inside of it. And then at the top, we do a single await to wait for all of them to resolve, and then put all the strings back together. So what this gives us, so this is a new compilation strategy. What the new renderer gives us is we can use async setup to serve as a generic hook for async work during server-side rendering. You can use it to fetch data, do code splitting, caching, anything you want. It's all handled under the same async mechanism. And it offers you maximally parallelized async rendering. So let's say you have a list of 1,000 items. Each of them are performing some async work. The new rendering strategy will, in fact, render all of these at the same time. It'll dispatch all these async requests at the same time and wait for them to all finish, and then give you back the final string, right? And also seamlessly support mixing template and render function-based components, which means let's say you are writing a template and then you use a Vuetify component. Vuetify components are written with render functions, but you can use them inside your template-based render functions in the same app, in template-based components. You can mix and match them in the same app, and the renderer will just handle them just fine. The renderer automatically fallbacks to virtual DOM-based serialization when it runs to such components. So you get the performance benefits when you write templates, but you don't have to build. You don't have to, say, manually switch back and forth in order to leverage render functions. You can just use them if you want to. Okay, so that is server-side rendering. And the final piece is hydration. So as we talked about in the early phase, we detect these static parts inside our components, inside our component templates, right? So it turns out this helps with hydration too. When we're hydrating client-side content, we already know, so let's go back to the example where we have a big giant static tree. I need to copy this a few times to trigger the optimization. So when we have nodes like this, notice this call, create static vnode. So during hydration, our client-side app will match your virtual nodes to the existing DOM nodes that's already on the page. This is called hydration, right? So when we match them, we notice that, oh, okay, the current vnode is in fact a static node. So there's no point in going deeper into the tree. So we'll just match this div with this static node, and we're done. So we can skip all its internal content. So this applies for any kind of static tree hoisting, even if it's not string concatenation. Like, even if it's like this, we can still skip all the internal diffing on initial mount. So during hydration, we'll just look at this node, adopt the corresponding node, and we're done. So the area where this really helps is for static site generation use cases, like VuePress or Gritsum. Right? Let's say you have a huge piece of Markdown that's compiled into a Vue component. Most of the Markdown content is really static. So using the nuxt strategy, most of the time you'll just end up with a giant single static node, and the hydration process will literally be taking 0 time because it'll just look at it and know the whole page is static, and it just won't do any work. So this is another area of big improvement. Now, further possible improvement that we can do is when we have cases like this, the challenge here is we don't really know if this piece of content may get toggled or not. So in a static site generator like VuePress, there are some assumptions that we can make. We know when the page is rendered, the content will always be there. And we know that the content will only be switched or toggled when you switch routes. So with this kind of constraints in place, there are situations that we can simply say, create static node, and this will be empty, because this content will already be on the page. There's no point in sending the same content twice to the client. So your JavaScript bundle, inside your JavaScript bundle, all of this will be gone. And on hydration, this node will pick up the corresponding content from the HTML markup instead of having to duplicate it inside JavaScript. So this will allow us to ship even leaner JavaScript bundles for static site generators. There are some of interesting things that you need to do inside at the framework level to make this work properly, but I think we can make it work, for example, in VuePress, so that you will end up with very lean JavaScript bundles and very, very efficient hydration process. So this will make it effectively probably the most efficient server-side rendering solutions today. So that is for hydration. Another cool point about hydration is the hydration logic is tree shakeable. So if you don't need server-side rendering, it won't even bloat your bundle. This applies for almost all the non-essential features. Keep alive, transition, vModel, all these features, if you don't use it, it won't be in your bundle as long as you use a tree shaking capable bundler. Okay, so that is for hydration. And SSR is not fully completed yet. We still need to finish suspense support. So suspense is one of these new things that's probably the only unstable part, the most unstable part of Vue 3 right now. So we're finalizing the support for suspense in server-side rendering. We also want to improve the mismatch handling in hydration in case the rendered markup and your JavaScript code just doesn't match up. We need to somehow gracefully morph the DOM to match your JavaScript, and then put the server-side rendering compiler integrated into the SFC compiler, and then you will have something. We will have a demo that has whole server-side rendering flow set up, and the Nuxt team will be busy at work integrating into Nuxt. So that's it for server-side rendering, and that's also all for today. Thank you.
Thank you so much, Evan. That was wonderful. So I'm going to keep you here because I'm sure everyone in the audience has lots of questions. So we'd like to just ask you some questions before we move on to the next session. First of all, I'm sure I'm echoing a lot of sentiments here that there's a lot of excitement for Vue 3. And this question probably comes up a lot as to, like, when can we expect Vue 3? And is there an estimated date that will be released?
Right. So on the roadmap, I think we were aiming for end of Q1. So right now, like, to be totally honest, I think we'll most likely be beta very soon, in maybe a couple weeks.
Okay.
So whether we can actually do a final release for end of Q1, that's debatable, because I think most of the work left, we need the kind of work we want to finish before calling it an actual release are documentation, migration guides, migration tooling, and we want to also upgrade, say, CLI and dev tools and everything to match that. So at this stage, I would say that the majority of work on Vue itself, of Vue 3, is pretty much done.
Okay.
But it will take some time for us to just like give us, so the goal is to give everyone a good upgrading and migration path. So that kind of work will probably take a bit more time. So I think the safest to say is we'll definitely be beta before end of Q1.
Okay.
And that is to say when we reach beta, the API will mostly be stable. There might still be bugs. So the beta phase, we will encourage people to start building small applications with it, try it out, give us feedback while we work on all these migration materials.
Yep.
And once that is done, we will launch the new documentation and everything. That's mostly in Q2.
Yeah, that's really exciting.
Yeah.
Can we have a round of applause just for like,
Thank you.
yeah, that's awesome. Cool. So for those of us who are really excited to use Vue 3 and are like anticipating the release of it, there is an ability for us to already start working with that, is there?
Yes.
With Vue Next?
Yeah, so if you look at the Vue package, we already are releasing 3.0 alpha releases. We also have a working Webpack-based setup that you can try things out. So just go to the Vue Next README and you'll find a link to the Webpack setup and just clone it, install, and you'll get running. Yeah.
So there is some feature parity between like what we will expect in Vue 3 and what Vue Next is at the moment, is there? Or like
Vue Next is Vue 3.
Okay, yeah.
Yeah.
So it's just
So-
a way for you to work with certain sections of it, like the composition API or various part like slots and things like that.
Well, everything is in there.
Okay.
So if you see something in the RFC, it's likely already in the Vue Next.
Okay.
branch. Yeah.
No, that's really cool.
Yeah.
I guess the next thing is that it's really exciting to see that Vue 3 has first-class TypeScript support, because I think for a long time that has been something that has been a second-class citizen. If you want to use TypeScript, it's a completely different way of writing Vue. So will that mean that there is type inference within
Totally.
Vue itself?
In fact, let me show you.
Live demos are the best.
So let me make this a bit bigger. So I'm inside Vue Next right now, and so how should I demo this? Let's see. If I create a demo.js file here, and I say import create app from Vue. I hope this. Oh, okay. So let me import it from runtime dom, because I'm in a local setup, and TypeScript only knows to pick up the definition for that. So notice that I'm using JavaScript. This is not TypeScript, but it's still telling me this API signature of the thing. And in fact, if I do create app, it actually completes the import for me. So const app. As you can see, this is all because we have first-class type definitions. The source code is written in TypeScript. And during build, every package, we generate the type definitions for it automatically, so we don't have to manually maintain it and upgrade it on every release. And these type definitions will get picked up by IDEs like VS Code, hopefully WebStorm as well. And even if you're using JavaScript, the IDE will still be able to leverage all these type definitions to give you auto-completion and all that. So if I say data return A1 and methods foo. Does this work? No, unfortunately. If this is a TypeScript file, it'll work. So you'll get an actual proper inference here. Now, what's good, another important thing that we want to see is if you're using the composition API, say ref, so I auto-imported ref here, so count, equals ref1 count dot. Okay, so in JavaScript, you don't get this type of auto-completion. Yeah, it does, actually. Yeah, so it shows like count is a ref, and shows it's actually a ref containing number type, and you can auto-complete the value here. My computer was probably just a bit slow. So you can do this, and the best part is, if I convert this file into TypeScript, notice that it's just valid TypeScript. You don't need any manual type hints for that. It just works. So in reality, the code that you write, especially when using composition functions, the code you write in JavaScript and the code you write in TypeScript will be 95% identical. So that's the best part, right? First, JavaScript code and TypeScript code in Vue 3 will look almost identical. Second is, no matter if you're using TypeScript or JavaScript, you'll be able to benefit from the type declarations. So the real benefit when you really use TypeScript is like the actual tooling, like when you build your files, it'll like catch errors and warn you. If you use JavaScript, it'll just ignore the errors, obviously. Right? So, but overall, I think like this is much better than I think this is better than a strategy that would force you to use a syntax that's dedicated for TypeScript. But if you say, I want to use JavaScript, you have to like fall back to a worse syntax or something, right? So I think the best type of TypeScript support is that kind of seamlessly allows you to transition between JavaScript and TypeScript and provides you the same kind of benefits. So I think that's the main goal that we're trying to achieve with
So this
Vue3.
would mean that you're no longer, when you write TypeScript, because in the past you would have to basically use a class API in order to use TypeScript.
Yep.
So the assumption here is that you no longer have to write it that way, or do you have the option of writing it that way if you want to?
If you really, really like classes, Katashin is still going to be working on class component support.
Okay.
But that's not going to be the default.
Yeah.
Right. If you want to start using TypeScript with Vue 3, the most straightforward way, obviously, is just change your file extension to TS, and you can get going.
Yeah. Cool. That's awesome. And then that definitely deserves a round of applause for sure, especially for the TypeScript audience or people who really like it. I guess the next thing would be that with Vue 3, or moving from Vue 2 to Vue 3, one of the big things was the introduction of RFCs, and that allowed the community to be more involved in the process of understanding what was happening, how features were being implemented, and so on. How do you feel the success of that has been overall as you're working on Vue 3? Have you actually looked at certain feedback and taken that into consideration?
Definitely, yeah, a lot of cases. I think the whole function API to composition API and all that, we definitely took a lot of feedback, basically scratched our ideas a few times, trying to think about what's the best way to go forward. And even just yesterday, we're still kind of having discussions in the RFC repo regarding some of the parts about the composition API. There might still be some small changes that we need to apply. So it's been an ongoing process, which is really good because like in the past, some of the things we've done in the past is like, we design a feature, we're not even sure ourselves, but there was no way for us to collect wider feedback without actually just shipping it.
Yep.
But once you ship it, because there is a lot of more inertia or resistance or friction for you to actually change it. But having the RFC process essentially allows us to sort of lay it out first, and we, in fact, get quite some very insightful feedback because like there are often areas, like as a developer, as a single person, there are areas you usually tend to sort of neglect during the design process, and having extra sets of eyes really helps.
Yeah, definitely. And I think that coupled with the RFCs coupled with Vue Next was really good because it allowed a lot of us to work on not just looking at what was happening, but also implementing it in our own applications to try it out.
We actually received tons of pull requests in the Vue Next repo. I think we've merged over 200 pull requests now.
Wow.
Yeah, and a lot of them are like first-time contributors who've never contributed to Vue 2 in the past. They read the RFC, they read the code base, and they just started working on features, which is really I think that kind of shows the success of this model. We are actually getting contributors, even if we didn't really like have a very thorough guide on how to actually work on the new repo. A lot of people just figured it out themselves.
Yeah, I think that's fantastic, and it's definitely telling that it's a pretty successful endeavor itself. Along that point, I think the composition API is like a huge difference between Vue 2 and Vue 3, and having worked with it and having talked to a lot of people, and I'm sure in the community as well, like in this audience, a lot of you have worked on it. Like one of the biggest things is trying to convince people why they would use it, or even just, I think the general feedback that I've gotten from people is just, oh, the current syntax is great. Why would I want to move to this other complicated other thing? So what is your, I guess, comments or feedback towards that particular sentiment?
So personally, like right now, my position is that if you have strong preference on which syntax you would want to use, just go with your preference. The real benefits of the composition API really shines when you are authoring reusable utilities or libraries or plugins that need to inject external logic into your current component. And I think that's an integration point that really works well. Say you can have components, especially say if you have a legacy 2.x application with a lot of components already written in the options API syntax. You don't really need to change it. You can still start using, say, a library written using composition API. In order to use it, you just add a setup function to your current options-based component, and then just inject the stuff from the external library, and it'll just work. So there is really nothing that forces you to migrate everything, nor are there something that prevents you from using composition API in an existing options API code base.
Yeah.
So, so I guess the takeaway is don't think that you have to upgrade everything to composition API. You don't. If you're starting something new, go with the syntax that you prefer for your presentational components or for your, I would say, feature components. But if you're authoring something that's reusable, a utility that you want to reuse across components, or a library that you want other people to use, then you should start doing it in composition API instead.
Yeah, I think that's a really important distinction as well, just because from a migration standpoint, instead of, I don't know, pulling a specific move where you're like, we're no longer going to support Vue 2 and behind, it's not backwards compatible and you have to move towards it. I think that automatically loses a lot of people in the community because they feel this need and rush towards moving over. And if you're working on a legacy system, or if you have a lot of code, that can be a huge endeavor. And so, that's
at the very least, you will be able to use the composition AI as just a better replacement for mixins. That's for sure.
Yeah. So mixins will definitely not be the pattern that is recommended moving forward.
I would discourage people from using mixins from now on. Now that composition API is available.
Yeah, because it's an accurate alternative itself. Thank you so much for your time.
Thank you.
I think we're going to move on to the next speaker. So you can.
Thank you.